So this video is going to talk about what we call acid-base indicators, and these are going to be chemicals that we use in different labs to determine what the pH is based on a color change. So they are what we call weak acids, and they turn colors in both acidic or basic solutions. So the one that we are most familiar with at this point is something called phenolphthalein. And we'll be using them also, using phenolphthalein in a titration later on. But phenolphthalein will turn pink in bases, but it'll be clear in acids. So that's the most common indicator that you're going to see, but there's a few other ones that we're going to use in the lab and a couple other practice problems. So one is called Methyl Red. And this indicator, when you put it in a solution, is going to change color only when you're in a pH of 4.2 to 6.2. So methyl red turns color in a range of 4.2 to 6.2. So what exactly does that mean, and how can we use that range to get us some information when we see this in the lab? So the different colors that it turns is red and yellow. Red color is indicating that you're at a pH less than 4.2, or another way you could write it is 0 to 4.2 as a range of pHs. If you have a yellow color, again, what is the highest point of this range is 6.2, so say greater than 6.2, or you could say 6.2 to 14. And then if you mix red and yellow, you're going to be orange. So you are somewhere actually directly in this range, 4.2 to 6.2. So if you have a mixture of the two colors that are on the ends, that's essentially telling you that it is in the middle of that exact range. So for this, I want to switch my screen. One moment here. Here we go. So this is a mostly how books promote essentially, or how they write in their books, acid-base indicators. So if we look at our example here, methyl red, you will see it is red here on the left and it is yellow here on the right. And where it is red is about 4.2 and where it's yellow it's about 6.2. So what's sometimes confusing for students is the fact that all of this below 4.2 would make a red solution and anything above this would be yellow. In the middle then, if you're in that range, you're probably orange. So these different indicators that you have on this chart have different ranges of where they turn color. So you could use a combination of these indicators to kind of give you a better understanding of what the pH is of the solution. So let's go back to camera. Okay, so if we look at Bromocrystal Green, okay, Bromocrystal Green is another indicator. It changes between 4 and 5.5. So again, the colors will be given to you. Okay, yellow would mean you're at the bottom end of this range. So that means I am below 4, or I could say I'm between 0 and 4. If it is blue, that's the outer edge here. That's going to be 5.5, so greater than 5.5, or you could say 5.5 to 14. And then if you are a mixture of the yellow and blue, making it green, you are somewhere between 4 and 5.5 exactly. Okay, so there's many different indicators that we could use, but those are the two we're going to use in our lab and in our examples. You could also use different kinds of paper. Now, the one that you might be familiar with is pH paper. pH paper, you might use it at home with an aquarium or with a pool or hot tub or something like that. It is paper that is dunked in what we call universal indicator. And so it will turn color in all pHs. And so technically, you usually see pH paper as purple for base and then more reddish for acids. pH meters, we don't have any at school, so I'm not going to show you any of that. But litmus paper, pink litmus paper, is going to stay pink in acids, but it will turn blue in a base. Okay, And blue litmus paper is going to stay blue in a base and it will turn pink in acid. So really what you will use litmus paper is you will put both pieces of paper into the solution and see which one turns color. If it just looks like it turns like it got wet, you could just say it is the acid or the base. If it turns color, then you have confirmation that it is definitely a base or an acid. But litmus paper is not as reliable just because of where it is located. Or where it changes color. So with this, all right, so I'm going to go through an example with you so that you could kind of see what this is about. So this is a worksheet that you should have available to you. And you will always be given what I call a pH chart like this. So that's not something that you're going to have to memorize or kind of, you know, understand or think that you won't be given this on a quiz or a test. So we have the 4 indicators we're going to be using in our lab. We have litmus paper, Bromothymol Blue, Phenolphthalein, and Methyl Red. And what I'm going to do is put underneath each one what the color change is telling me about the pH range. So if blue paper turns pink, we are going to assume that it is less than 7, so that it might be in acid. If pink paper turns blue, we're going to say that it is greater than 7. All right, so Bromothymol Blue turning yellow, again, it's going to be on the end of this range, so it's going to be less than 6.0, or you could say 0 to 6. If it is blue, it is greater than 7.6, or you could say 7.6 to 14. And if you have the range exactly 6 to 7.6, then you could say that it is a mixture of those 2 colors, which in this case is green. Okay, phenolphthalein, colorless and anything less than 8.2. Pink, we're going to say greater than 10, bright dark pink in front of the pink that you have there. So greater than 10 is really going to be a pretty dark pink, even closer to red. And then if you're between 8.2 and 10, you're going to say a light pink, where this is really where it starts to change. So since you're going from no color to color, you kind of have that transition. It's a little different than the other colors that you see. All right, so see if you could try methyl red with the red and yellow and see if you could predict what this color is going to be. So hopefully you realize it's less than 4.2, greater than 6.2, and the color should be orange in that range of 4.2 to 6.2. So what are you going to do with this? Well, you are going to test these 7 unknown solutions with all of these, and you're going to see what colors they are. And you're going to estimate a pH from their colors. So my suggestion is underneath each color, you're going to put essentially what is that color telling me about the pH. So if blue turns pink, I'm going to assume that I am less than 7. Okay, but litmus paper is not going to be the most reliable out of the 4 that you have here. Bromothymol blue is yellow. So go up to the chart and say, okay, yellow is telling me I'm less than 6. So write down less than 6. Phenolphthalein is colorless. So colorless means I am less than 8.2. And methyl red being red, I am less than 4.2. So what you have to do is figure out which one has the narrowest range, or a way to think about it is think of it as like a number line. So we have 8.2, we have 7, we have 6, and we have 4.2. Okay, so we know that it is less than 8.2, we know it's less than 7, we know it's less than 6, we know it's less than 4.2. So which one is going to be the most limiting out of all of these is the 4.2. So again, however your brain can get around it, you could write 0 to 4.2, or you could just say less than 4.2, either is acceptable. But that's what you're doing on this sheet, is just to get some practice before we go into that pH lab. And you're going to have data to kind of look at. So this will kind of give you some practice with that.